going to talk about how to predict customer churn. Customer churn or customer attrition happens whenever a customer stops using a service or stops doing business with a company. Companies are very keen on keeping existing customers since it's far less expensive than acquiring new ones. The ability of predicting churn is necessary for a business to be able to prevent them from discontinuing their subscription. This also gives businesses a better understanding of future expected revenue. Predicting churn rates can also help your business identify and improve upon areas where customer service is lacking. And by making those improvements, you can decrease churn and improve revenue numbers. For this tutorial, we will create a simple churn prediction model using Alteryx. The dataset we will use today is from IBM Watson's Analytics community. The complete documentation and information is available on both Kaggle and IBM community page. The objective of our model is to determine the percentage of churn for each customer. As the first step, let's explore the data. Alteryx has implemented a nifty profile tab on the Browse tool, which shows us the basic graph of the unique count of records for the highlighted field. In this case, we have selected Customer ID. This shows the total number of records displayed. Our dataset has 7,043 lines. It also gives us insight on the data quality. And it shows if the specific field has any null, empty, or truncated rows and other useful information. But if you wanted to check the data for all of the fields, it would be more efficient to use the Field Summary tool. This tool gives us a concise summary report of the descriptive and statistics for the selected data fields. I have configured the tool to give us a report for all of the fields available. You can still deselect any fields that you do not need. There are 3 output anchors on this tool. O anchor has a data table with a complete descriptive statistics report. R anchor has the static report, and the I anchor has the interactive dashboard. Let's look at the interactive dashboard. We can see that each field has been taken in and graphed according to the count for each category. Clicking on the expand icon will give us more insight for each field. Based on the analysis, we have 2 types of data in our dataset, categorical and numerical. Most of the data which has the services is in categorical yes or no value. For example, if they ever enabled paperless billing, if they bought any additional streaming services, any phone service, or none. The rest of the fields has less than 4 instances of unique categorical values. There were also some numerical data that needs to be converted, such as monthly charges, total charges, and the tenure. To prepare the dataset to be used in the model, we need to encode the categorical instances to a numeric one, meaning yes and no value will be converted to 1 or 0. In this example, we are substituting each field that is either yes or no to 1 or 0 by using an if statement for the categorical fields. Before heading to the other fields, we also converted the processed categorical fields to 1 integer. This changes the field itself and the data to an integer 64. Next, we have encoded each categorical instance for every field. To do that, we need to add a new integer field which will signify the value for each instance. For example, since we just can't have gender as 0 or 1, we have created two new fields called gender female and gender male. So if the customer is a female, gender female will be 1 and the other will be 0. This has also been applied for internet services, contract, and the payment method. Then we need to separate a training sample from the test dataset. Right now, we're going to get 80% of our dataset from the model. By using a create sample tool from the preparation toolset, configure the estimation percent to 80 and the validation to 20. The machine learning algorithm that we're going to use is the logistic regression. This tool is available in the predictive toolset. This is mainly used when we're trying to relate a binary target variable, in this case our churn field which has either yes or no, to one or more predictor variables. The output will then be the estimated probability percentage, which will always be a value between 0 and 1. In setting up the tool, enter a model name. Select your target variable, in this case we're calculating churn. Select the appropriate field from the drop-down list. Then select the predictor variables from the list. Right now we have deselected the customer ID since it's a unique value per line and the three categorical fields that we already grouped by its instances. You can also click on the Customize button for further adjustment in your model. To view the churn score output of our logistic regression tool, we need to add the score tool. First, connect the e-anchor of the sample tool to the data or the d-input anchor of the score tool. Then, connect the o-output anchor of the logistic regression tool to the m or model input of the score tool. Once done, set the configuration of model type to a local model. The output of the score tool is the percentage of the probability for every instance available in churn. In other words, it's going to tell us if it's more likely to churn or more likely to not churn. To avoid unnecessary confusion, we only need to select the x_yes or the probability of churn. Then, using a formula tool, convert the decimal to a percentage by multiplying it to 100. After all of that, we can now remove the other fields and join it back to our original format. Using a join tool, join back the output to our first select tool and set the customer ID for the join. Then our output is done. You can now add an output data tool to save it as a file or feed it directly to your SQL table.